Hello friends, in this video we'll be discussing Laplace transform of derivative property, problem number 2 and 3. Welcome back friends. Let's discuss problem number 2 and 3 on Laplace transform of derivatives. In the last video we discussed what the property is and we discussed one example on it. Let us move on and let us discuss two more examples. Now starting with problem number 2, here we have d by dt sine 3t upon t. Very simple. Look at this particular problem. This is your Laplace transform of derivatives. Forget about it. Find Laplace transform of sine 3t upon t first. Let us do it. Here my f of t is sine 3t upon t. We need to find Laplace transform of this particular function. Here this t indicates effect of division by t. Forget about it. You are left with what? Laplace of sine 3t. And what is that? 3 upon s square plus 9 by effect of division by t. Laplace of sine 3t upon t. Due to this t, I am going to integrate it from s to infinity, 3 upon s square plus 9 into ds. What next? Integrate. This 3 you can take it out and you will be left with 1 upon s square plus 9 into ds. So its integration is formula number 4, 1 upon s square plus a square, 1 upon a tan inverse of s by a, 1 upon 3 tan inverse of s by a. A is 3 because this 9 is a square. A will be the square root of this. So that is 3. And limits are from s to infinity. Let us put the limits. That will be equal to, if you put infinity, that will become tan inverse infinity, that is pi by 2, minus. If we put s in place of s, if we put s, that will remain as it is. In short, pi by 2 minus tan inverse is what? Cot inverse of s by 3. So this is the required solution of sine 3t upon t. What next? We got the solution for this. Now we're going to apply Laplace transform of derivatives. And we know for finding Laplace transform of derivatives, we need a term that is f of 0. So let us find it out, that term. F of t is sine 3t upon t. We need to find out f of 0 as discussed in the last video. Finding f of 0 means we gonna take the limits. So limits t tends to 0 sine 3t upon t. If we put in place of t as 0, so that will become, this angle will become 0 and that will become sine 0, and sine 0 we know is what? A 0. If we put here 0 in place of t as 0, that will become 0 by 0, and 0 by 0 as discussed in the last video, we are going to apply L'Hospital rule. And what the rule says? Numerator derivative, denominator derivative. Let us do it. This is limit t tends to 0 sine 3t derivative, chain rule. This is your f of x. That will become sine fx. Sine fx is cos fx, that is cos 3t, into derivative of 3t. 3t derivative is 3. Or in short, sine 3t derivative is cos 3t. In case of derivative, we just multiply with the coefficient of t. Here coefficient of t is 3. We just multiply by 3 upon derivative of this t. Derivative of t is what? 1. Individually, numerator derivative different, denominator derivative different. Let us put the limits. If we put t as 0, now this will be t as 0. So this angle will become 0. This will become cos 0, and cos 0 we know is as 1. So this will become 1. If we put t as 0, this will be cos 0, and cos 0 is 1. So basically the answer is 3. How? This is 1. 3 upon 1 is what? 3. This is the value of f of 0. Finally, Laplace of d by dt of sine 3t upon t. Yes, sine 3t upon t Laplace is what? Cot inverse of s by 3. And because of this differentiation, I'm gonna put s here and minus f of 0. And what is f of 0? F of 0 in case is 3. So that 3 will come here. Done with problem number 2. Let us discuss problem number 3. Problem number 3 is d by dt of sine squared 2t upon t. Here I'm discussing this example in the same video because I'm not going to find Laplace transform of this. That you need to do it by yourself. Have you seen this question before? First of all, tell me this. Have you seen this problem before? Yes. Type number 4, problem number 3. Go back and check. In type number 4, problem number 3, we have already tackled this. So let me write it down directly, answer for you. Laplace of sine square 2t upon d is equal to 1 upon 4 log of s square plus 16 upon s square. If you want to check, you can go and check type number 4, problem number 3. Go back and check. I have provided you the detailed explanation. If you remember, well and good, you can continue with me. But make sure that while solving this type, solve this completely and get this solution. Therefore, then it will be a good practice for you people. Let us move on. Here we just need to find out f of 0, sine square 2t upon t. We need to find out f of 0. So here f of t is sine square 2t upon t. So sine square 2t again you can write down as 1 minus cos 4t upon 2 into t. This is sine square 2t. That is what? 1 minus cos 4t upon 2, and this t will remain as it is. F of 0 discussed number of times that we're gonna take limit. Limit t tends to 0. 1 minus cos 4t upon 2t. Let us put the limits. See here, after putting the limits, we got 0 by 0, and which is not a valid solution. Therefore, we moved on and we took L'Hospital rule. Let us check. After putting t as 0, what we getting here? If we put t as 0, see here, if we put t as 0, this will become cos 0, and cos 0 is what? 1. If you put t as 0, this angle will become 0, this will become cos 0, and cos 0 is 1. So this will become 1 minus 1, and 1 minus 1 is what? 0. And if you put t as 0 here, that will be 0 by 0. 0 by 0, we need to go ahead with L'Hospital. What L'Hospital says? Limit t tends to 0. Denominator derivative is very simple. It is 2. 2t derivative is 2. In the numerator, this one derivative is 0. So this minus will remain as it is because one derivative is 0. Cos 4t derivative is minus sine 4t. It's minus cos 4t, right? So minus as it is. Cos 4t is what? Minus sine 4t. So minus sine 4t, derivative minus, and this minus will become plus. So in short, it will be sine 4t into 4. How come this 4? Here also we discuss this. Sine 3t derivative is what? Cos 3t, and whatever is the coefficient of t, we're going to multiply by that term. Same story here. Cos 4t, its derivative is minus sine 4t. So that minus and this minus will become plus, and sine 4t into multiply by the coefficient of t, and the coefficient of t is 4. So 4 will come here. Let us put the limits. Let us put t is equal to 0. If we put t 0, see this will become 4 into 0. This angle will become 0. Okay. If we put t as 0, this angle will become 0. This will become sine 0. And what is sine 0? 0. 0 into anything? 0. Upon, in the denominator we have 2, so that is 0. Please tell me, shall we proceed with L'Hospital? Yes or no? No. Why? L'Hospital, when it is applicable? L'Hospital is applicable if we getting 0 by 0 or infinity by infinity. Any result which is not a finite. If the result is not finite, then we apply L'Hospital rule, like here 0 by 0. In the last video also we discussed that. Here also 0 by 0. But friends, 0 is a finite result. 0 by 0 is infinite, but if you get only 0, 0 is a finite result. So this is finite and this is acceptable. No need to go ahead with L'Hospital. This is 0 result and which is acceptable to us. Okay, so what is the final conclusion? So finally, d by dt of sine square 2t upon t is equal to, yes, s into Laplace of sine square 2t upon t, which is this, that is 1 upon 4 log of s square plus 16 upon s square minus f of 0, and f of 0 is what? 0. That is it. So that is the required solution for this particular problem, sine square 2t upon t. Hope you understood. We're done with it. Thank you.